Alright guys, today we are going to talk about mid-segments of a triangle. So at the end you should be able to identify mid-segment, use mid-segments to find missing sides, missing angles. Shouldn't be too bad. So here we go. A mid-segment of a triangle is just a segment where we connect midpoints of two sides. Okay, so if I have a midpoint of one side and a midpoint of another and I connect it, that's called a mid-segment. Okay, now the mid-segment theorem is if a segment joins the midpoints of two sides of a triangle. So if it's a mid-segment is going to be parallel to the third side and half its length. Okay, and so one way to prove this is just to use similar triangles. So let's say we got this side. We're going to say it's 12. Try to put these really quick. 12. I'll make this 14. I'll make this 10. Okay, this whole side. This whole side's 12. This whole side's 10. This whole side's 14. Okay. So I'm going to label these A, B, and C. You'll have to draw this triangle because it's not on your paper. I drew it, you can tell, because it's not that good. Well, let's say we have a midpoint here. Okay, this midpoint. Okay, if it's a midpoint, then this is 6 and 6. This will be 5 and 5 because this whole side's 10. Okay. All right. So we connected two midpoints. I guess I should label these points D and E. Okay. So we connected these two midpoints. So here DE is a mid-segment. Okay, it's the line that connects two midpoints. Well, let's talk about these two pieces of the mid-segment theorem. It says if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half its length. So let's look at it. If it's half its length, then that means this should be 7. Let's look at why that will be true. Okay, we just got done with the similarity chapter, so let's use the similar triangles. If we have our two triangles, so I have my small one, my small triangle, ADE, okay, which is 6 here, 5 here, and I have my large triangle, which is ABC. Okay. Well, this whole side is 12, and this is 10. Okay. So we should look at it and see that our similarity ratio is 1 to 2. 1 to 2 here. And we also have this shared angle. Okay, so by side angle side similarity, I know that these two triangles are similar. Okay, so similar triangles with a 1 to 2 ratio. If this is 14, then I know that my mid-segment has to be 7. Has to be 7. Okay, so prove that that's right. It's half its length. Alright, also, because these triangles are similar, that means all their angles are congruent. So this angle is congruent with this angle. Okay. Also, these two angles are congruent. But we'll just stay here. What type of angles are these? These are corresponding angles. If we know that corresponding angles are congruent, then by the converse of the corresponding angles postulate, we know that these lines have to be parallel. So there, we just proved that mid-segments are half of the side of the side they don't intersect and parallel to it. All right, so that's proving it and using it. Two different things. Let's use it, and we'll go through a couple of sample problems here. So first one, we have M, N, and P as midpoints. They told us that MP is 22, that MN is 24, and the perimeter of MNP is 60. Okay, so I guess since we know that that's 60, 22 plus 24 is 46. 60 minus 46 should be 14, right? Okay. All right, they want us to find NP. Oh, just did that. Okay. And they want us to find YZ. Okay, so in P, that was just like a subtraction problem, perimeter, not too much that we had to worry about. YZ more relates to the mid-segments. What's YZ? How do we find YZ? Well, we have YZ's mid-segment. Okay, because this is a midpoint. They told us that these are all midpoints. This is a midpoint. And so this side should be, its mid-segment should be parallel to it, so the only line that doesn't touch it, and half its length. So if this is 22, then YZ should be 22 times 2, or 44. Okay. All right. Number 2 says find the measure of angle AMN and the measure of angle ANM. All right. So looking here, again, we have N as a midpoint. We can tell because of these markings. M as a midpoint. We can tell because of these markings. So this is a mid-segment, and M is a mid-segment. Okay. They're asking us for angle lengths or angle measure, so it doesn't really matter about the lengths, and they don't give it to us anyway. But we know that these lines are parallel. Okay. If these two lines are parallel, and M is parallel to CB, then their corresponding angles are congruent. Okay, these two are corresponding angles. So the measure of angle AMN should be 75 degrees. And these two should be the same as well. Okay. And now what kind of triangle is this? ACB. ACB is going to be an isosceles triangle. We can tell because the side lengths are exactly the same. Okay. So whatever this is, let's just say it's x and x, x and x. It means this side length is 2x and this side length is 2x. Okay. So ACB is an isosceles triangle. So that means if this is 75, this should also be 75. They're actually equal to each other. Okay. So A and M is 75 degrees. All right. CD is a new bridge being built over a lake as shown. Find the length of the bridge. All right. So they told us that this is 963, this is 963. So C is a midpoint. They don't tell us what this is, but they do say that they're the same, those markings. So D is a midpoint. This is a mid-segment. Okay. The mid-segment, we know, should be half the length of the third side. Okay, so if this side's 2,640 feet, okay, this mid-segment should be half of that, which is 1,320 feet. All right, flip to the other side. All right, so here we go. This is a thinker a little bit. It says the perimeter of a triangle is 78 feet. Find the perimeter of the triangle formed by its midpoint. Okay, a couple ways you can do this. I'll do this the long way and then I'll do the short way. Both of them aren't very long. Okay, so if the perimeter of this triangle is 78 feet, I'm going to make a triangle that has that perimeter. 20, 20, 38. Okay, doesn't have to be those side lengths, but I want to make a triangle that adds up to 78. They want me to find the perimeter of the triangle formed by its midpoints. So I'm going to make a midpoint here, midpoint here, midpoint here. I'm going to connect them. Okay, so now if I look at this triangle in here, because that's the one that really matters for this question, triangle formed by its midpoints. If I look at that triangle here, what are these mid-segments' lengths? Well, this one should be parallel to this line, right? So if this line's 20, mid-segment's length is 10. If this side's 20, this mid-segment's length is 10. This is 38. This should be half of that, which would be 19. So we have 10 plus 10 plus 19. The perimeter should be 39. Alright, let's see how this perimeter, 39 feet, let's see how this perimeter relates to the perimeter of our original triangle. How are these two related? The perimeter of our midsegment will be, or the triangle formed by the midsegment is going to be half of the perimeter of the triangle. It only makes sense since all the midsegments are half the length of their sides, or their corresponding sides. So, two ways you can do that. You could have thought about it and said, hey, that has to be half of it. Or you can make up your own triangle as long as it has the perimeter of 78, and it will add up to 39. Alright. Number 5. And take a second to pause it if you so you can test yourself out and try to answer these on your own. Number 5, only one of the lengths A, B, and C can be found. Name the segment and find its length. Alright. Only one of them can be found because we only know how to find the length of a midsegment. Now this is kind of a definition question. What is a midsegment? A midsegment is when you join two two midsegments, okay, with a line. So, two midpoints with a line. So 4 and 4 are here, so that means that this point's a midpoint. Cuts that side in half. 3 and 3, that means that this is a midpoint. It cuts that side in half. 5 and 6, not the same. Therefore, this is not a midpoint. Okay, so none of the midsegments made, or none of the lines made with that point would be considered midsegments. So the only midsegment we actually have is B. B is the only midsegment. And we know that B should be half of the side it's parallel to. So B equals half of, that side is going to be 11. So B is going to be 5.5. Okay. Alright, last one, throw some variables in there. Say DE is x plus 5. And BC is 3x minus 1. And they want us to find the value of x. Okay. By this time, we should be used to hearing the word midsegment, and hopefully you guys recognize that x plus 5 is the midsegment. Okay. So since x plus 5 is the midsegment, what we'll do, two ways that you can do it, but I like to do it the way that doesn't involve fractions. This 3x minus 1 is double x plus 5, right? Because x plus 5 is the midsegment. It's half of this line. So looking at that relationship, I'll say 2 times x plus 5, I'm doubling this, should equal 3x minus 1. Okay, and so we can solve. That would give us 2x plus 10 equals 3x minus 1. X equals 11. Add 1 on both sides and subtract 2x from both sides. X equals 11. Okay, and so that's the value of x. I'll set up the other way, even though I wouldn't recommend doing it this way. But we've said the whole time that the midsegment is half of this side is parallel to, so you could have said 1/2 3x minus 1 equals x plus 5. Okay, these are equivalent equations. Either way works out, but this way makes more sense because you get to avoid the fraction. Okay, midsegments, not too big of a deal. They're parallel to the third side and half of it, and we should be able to use them now.